Hello, welcome to another video lecture. On this one we'll be looking at torque a little bit more. Now what I have here is I have a door stuck inside the physics stockroom, and I have a force gauge right here, and you can see the force on the screen right there. And if I pick up a 1 kilogram mass, hopefully it's calibrated to just about 9.8 newtons. You can see down there in the bottom of the screen. Now as I go here, we can look here. I have the door, and I've screwed in 2 little hooks. One is halfway down the door, and the other one is twice the distance. So we can see here, this one's 43 centimeters, just about. If we go here, there it is, the same distance, or just about roughly, further down the door. Now, so if I apply a force here to open the door, I apply a force, and we can see down here at the bottom of the screen, looking at it there, we have a force of, when I'm holding it right here, about 25 newtons or so. 25 newtons. Now what would we expect the force to be down here at the end? Well, if it's twice the radial distance further down, we're then going to have probably about half the force. So if we open this up and we hold it in a steady spot, it's a little less than half, but it's pretty close, so we're a little bit further down. It's about 10 newtons. Before we had, I believe we said we had 25, right? Or 26, 26, yeah, 25. So it should be, it's a little bit, oh, there's 22, 21, so in that, so it's actually pretty accurate that we would have just about 10 down here at this point. 10, 11, 12, so right in the range of half the amount of force. Now, I can do this, I'm going to try and do this right now with a graph here. So if we start collecting data, we have the force here, that stage, and then I have the force here. And if we look at the force in the first part there, in the stationary part, it's about half of the force when I move the radial arm in. Now, the second thing I want to look at and show you with this force gauge is what's going to happen when I change the angle. In both of those cases, I had the force that I was pulling on the door that's causing this object to rotate. That's all a torque is. It's something that, a force that causes an object to twist or rotate. All I'm going to do now is change the angle. And to show you what I mean, so if this is my radial arm, instead of applying the force on at exactly perpendicular as it's moving around, what I'm going to do is I'm going to say, let's apply it at some angle and see what happens, and see how that increases. If we were to look at our equation, we should understand and expect it to, as we move away from the perpendicular, we should expect that a force, the necessary force, to increase for the same radial distance. So let's say we're going to clear this and start all over. So here we go. And we have, oh, I'm going to start this once again. So here we have a constant force at one angle, at perpendicular. Now I start to change the angle, and I'm spinning it here, and you can see how the force is increasing. And I'm almost, so the force increases as it goes up. Let's look. Starting perpendicular again, and now I'm going to swing it the other way. And you can see the average force is increasing as I have to apply it at a greater angle to hold this door in the same position. The big thing here, and one of the things we're going to look at, we're not really looking so much as objects rotate, we're really looking at them in equilibrium. So rotational equilibrium. What forces are counteracting them? Now, one of the forces we have on this door, if we open up, there's a, I forget what it's called, but it's basically a spring that's going to pull the door back closed automatically. And so basically what this force gauge is doing is opposing that force. So right now the door is in equilibrium because it's not rotating. It's not twisting, the acceleration zero. So we could say it's also rotational equilibrium. And that's really what we're going to be looking at with torque in this unit. Hopefully this was helpful in understanding torque, and have a great evening. Come in and ask questions tomorrow.